Welcome to this video that looks at monetary values over time. The topics covered are real versus nominal prices, and there we will look at indices like the Consumer Price Index, the Personal Consumption Expenditure Index, the GDP Implicit Price Deflator, as well as the Producer Price Index. In the second part of this video, we are going to look at growth rates. So let us have a look at real versus nominal prices first. Now consider this introductory example where you have two time periods, and in the first time period you are earning $100. Consider the price of apples and milk to be $5 and $10 respectively, and at those prices you're purchasing 4 apples and 8 gallons of milk. If you do the calculations, you will see that you are exactly spending $100. Now consider time period 2, where your income is $120 and the price of apples is $6 and the price of milk is $12 per gallon. Again, you're purchasing 4 apples and 8 gallons of milk. Now the question is, has your income increased between the two periods? On one hand, you are earning $120 in the second period compared to $100 in the first period. There you can say that your income increased by 20%, but note that your consumption hasn't changed, because in both periods you can still only consume 4 apples and 8 gallons of milk. This is an example where your nominal income, this is what you see on the price tag, increased from $100 to $120, but your real income, meaning what you can actually afford, has not increased, in the sense that your real income has stayed the same. Because not only did your income increase by by 20%, but also the prices of apples and milk increased by 20%. Now think about the situation where your income is $110. Now in that case, your nominal income increased by 10%, but your real income actually declined, because at the prices of $6 and $12 for apples and milk, you cannot purchase the quantities of 4 apples and 8 gallons of milk anymore. Hence, when we are comparing prices over time, we have to take into account that the purchasing power has changed over time. Now, before we start to assess of how we can actually make the calculations going from nominal terms to real terms, let us first have a look at what are called index numbers and indices. Now, an index number is a single value assigned to several individual numbers in order to quantify trends. Think about, for example, your GPA or your semester GPA. You can consider that a single number summarizing the performance in individual classes. Now, an index is a series of index numbers used for tracking over time. Now, in economics, index numbers or indices are important in order to differentiate nominal from real dollar values. We are going to look at the example of the Consumer Price Index, but there are also other indices, for example, the Dow Jones Index or the S&P 500 Index, which are stock market indices. So for example, for the S&P 500, there are a little bit over 500 firms in that index, and every day the value of those firms is summarized in a single number. Now let us have a look at the Consumer Price Index. Now, the Bureau of Labor Statistics defines the Consumer Price Index as a measure of the average change over time in the prices paid by urban consumers for a market basket of consumer goods and services. Think about the following example. Suppose I give you $100 and you're going to the grocery store and you are purchasing goods in the grocery store for exactly $100. Then a month later, you're going back to the grocery store and you're purchasing the exact same items that you have purchased a month before. Most likely, those items are going to be a little bit more expensive in the sense that you're not purchasing goods for $100 anymore, but it may be, for example, say $100.40. Now, the consumer price index is just that, but it's not a small market basket, but it's actually a market basket of about 80,000 items. About 15% of those items are food and beverages, there's housing in there, there's apparel, transportation, medical care, recreation, and so on. Now, the Bureau of Labor Statistics is tracking the prices of those 80,000 items every month, and hence can construct the consumer price index that is used in many economic policy analysis. Note that it says that the consumer price index is for urban consumers. How the consumer price index or how urban consumers are defined by the Bureau of Labor Statistics, that it covers about 87% of the US population. So it is a relatively broad measure. We will see that in economics, as well as in public finance, only real values or real dollar values matter. Now, how do we construct the CPI? Now, we are taking a market basket, and suppose that the value of the market basket is $68 when we first go. Okay, so that would be the market basket, or the value of the market basket in the base period is $68. Then, say a year later, we are purchasing this market basket, and now that market basket is actually $71. Then the CPI would be 71 divided by 68 times 100, and then the CPI would be 104.41 in the period T, and in the base period it would simply be 100. The CPI is used as an economic indicator and a policy target, and it is also used to deflate or adjust other economic series. It is also important to, for example, adjust dollar values, and especially during the COVID-19 pandemic, the CPI and also the inflation that can be calculated using the CPI has gained a lot of traction. Now, of course, there are problems associated with the consumer price index, because I mentioned before that you're purchasing the same market basket over time for many years. And of course, you can think about that the market basket or the goods that are in the market basket may change. So for example, there may be what is called a substitution bias, in the sense that if the price of a particular good increases, think about the price of beef increasing more than the price of chicken, then consumers might actually purchase more chicken. Okay? And hence you can think about this, that the consumer is actually adjusting their market basket. Of course, we also have new technologies that are usually changing the quality of the good as well. And again, when we say that with higher prices, people may actually switch to low discount stores. All of those problems relate that the quantity and the quality in the typical market basket changes over time. Now, the CPI, and I mentioned this before, is used to calculate inflation. Usually, the monthly inflation rate that is reported in the news is the percentage change in the consumer price index over the last 12 month period. Okay? So it is not the monthly price change, but it is the price change, the inflation over 1 year. Now, I have mentioned issues with the consumer price index before, and there's an additional issue that economists pay attention to, and that is related to food and energy prices. Usually, food and energy prices are very volatile. Think about bad weather and the subsequent decline in crop yields that may actually increase food prices, or there could also be fluctuations in the gasoline price triggered by changes in the oil supply. Because food and energy prices, although they are very important, they are very volatile and they may influence the CPI more than is desired. Economists usually exclude those items and they are just reporting what is called core inflation. Now, usually when you're including food and energy prices, that is headline inflation. So for example, in July 2023, the headline inflation, that is including food and energy prices, was 3.3%. And you can calculate those values when you look at the CPI in July of 2022, where the CPI was 294.628. Note that the CPI is unitless. And in July of 2023, the CPI was at 304.348. When you calculate the difference between those two values, then you're getting the headline inflation of 3.3%. Now the question is, where do you actually get the CPI data from? So the link or the office that is actually the agency that is actually calculating the CPI is the Bureau of Labor Statistics. And when you go on their webpage of the Consumer Price Index, which is bls.gov/CPI/home, then you are actually looking at here you're getting at the webpage of the Consumer Price Index. Now, if you're interested in the data, what you can do is you can click on data, you can click on databases, and then you see that you have the all urban consumers, the Consumer Price Index, and it is one of the top picks. So you can click on here. And then note that the CPI is not only calculated for all items and all urban consumers, but you can also have more detailed, for example, if you're interested in medical care, in energy, in food, prescription drugs, etc. There are many different categories. There are also many different regions. You can actually choose those series that you need. So let us use the all items. Note that we have here also the all items less food and energy. That would be the core inflation, whereas here we have the headline inflation. So let's take all city averages. You can click on retrieve data. And then here you have the information that you would need. As I mentioned before, you have the various inflation measures or the values of the CPI. And note that this goes back a very long time. So you can go, for example, you can look at 1980 and you see all the various values of the CPI. The CPI is set to 100 for the periods of 1980 to 1984. Okay, so that is kind of the base period, but since it is an index, this can be adjusted. Now let us get back to the presentation here. The CPI is just one measure of how you can actually convert real values and nominal values into real values, and we are going to look at this. But there are also other indices that can be used to make this translation or this conversion. One of them is the Personal Consumption Expenditure Index, or PCE, and this actually is an alternative to the CPI that is taking into account the changing composition of the spending. And hence, this avoids some of the issues that I talked about before, about the changing quantity and quality that is associated with the Consumer Price Index. Okay. Again, CPI and also the Personal Consumption Index are very similar though. To illustrate this and how they differ, here I have plotted the CPI and the Personal Consumption Expenditure Index between 1960 and today. And first of all, you can see that the CPI all items and the PCE, those are the red line and this blue greenish line. You see that there are much higher spikes and valleys actually. And again, this is associated with food and energy prices being very volatile. Now, the green line and purple line is without food and energy, and you see that the line is much smoother. Now, you can also see that whether you're using the CPI or the PCE, that they are very close in tracking the expenditure over time. You also see, of course, here you have the spike in inflation after the COVID-19 pandemic, but you can also see that the inflation has been significantly higher in the 1980s. Okay. Now, how do you convert nominal dollars into constant dollars? Okay. So here you have the equation, but in order to illustrate the equation, let us actually do an example. So think about gasoline prices in 1979. Now, gasoline prices in May 1979 were at 84 cents. But as mentioned before, you cannot compare 84 cents in 1979 to 84 cents today. What you have to do is you have to use the consumer price index to convert the nominal value of 84 cents into constant values in terms of 2022 dollars, so that you can make the comparison of how expensive was gasoline in 1979. So gasoline price in nominal dollars, this is what you saw at the pump, was at 84 cents. And the consumer price index at the time was 71.4. The CPI in 2022 was at 288.663, and hence the base year that we are interested in, or we want to express the gasoline price of 1979 in 2022 dollars, then what we have to do is we have to take the 84 cents divided by the CPI in 1979 and multiply it by the CPI in 2022. And we see that the gasoline price that was 84 cents in 1979, that in today's dollars is actually $3.40. Okay? So this puts the increase in gasoline prices in perspective. Very often you hear people that say that gasoline was 50 cents per gallon in, say, 1970 or 1960. But what they forget is that prices have changed over time. And you have to take that price change into account. To further illustrate this, that you cannot compare, say, 84 cents of gasoline price in 1979 to 84 cents today. An example that may be more appropriate would be the purchase price of a Rolls-Royce Silver Ghost of 1921. So this Rolls-Royce Silver Ghost in 1921 was about $12,000. Okay. Now a Camry today, a Toyota Camry today, is about $20,000. So you cannot say that the Rolls-Royce was cheaper than a Toyota Camry today. Okay, because the dollar value in 1921 was different than the dollar value of 2023. So it turned out that the Rolls-Royce Silver Ghost in 1921, that actually cost $12,000, was equivalent to the price of 3 Cadillac at the same time. Okay, think about that. The income or the wages were much lower in 1921 than they were today. Now, of course, you can always go through those calculations, but it turns out that the Bureau of Labor Statistics also has a calculator. So if we go back to the Bureau of Labor Statistics webpage, you have this CPI inflation calculator. And so, for example, you can think about the $12,000 Rolls-Royce in 1921. So this goes all the way back, actually. So let's do 1921. And you want to know of what is that core valued in today's dollars, in July 2023 dollars. Then you can hit the calculate. and you see that the $12,000 were actually equivalent to $193,000 in today's terms. Okay? So this CPI inflation calculator may be a very good alternative to the manual calculation you can do with this formula here. Let us next talk about growth rates. Here we are going to talk about the decomposition of growth rates, because usually there are two components. There is a real component, which is a change in the quantity of goods and services, and there's also an inflation or price component, which is related to the change in prices of goods and services. This relates to what we have seen before. To illustrate this, let us look at the federal government, national defense, consumption expenditures, and gross investments. Those values in nominal terms for 2010, 2019, and 2020 are summarized on this slide. So in 2010, the expenditures were about $828 billion, and in 2020 they were about $882.4 billion. Now at the same time, we also have the implicit price deflator. You can think about this as a more comprehensive alternative to the CPI, because it includes all products not only purchased by consumers but also by firms, government, etc. You can see how this implicit price deflator has evolved over the same period from 2010 for 2019 and 2020. Now the question is, when you're looking at the defense expenditures in between 2019 and 2020, as well as the price deflator for 2019 and 2020, then the question is, how much have the defense expenditures actually grown between 2019 and 2020? So let us do the calculations. So first of all, you have the general percentage change formula that can be either the xt plus 1 minus xt divided by xt, or you can simply simplify this by simply calculating xt plus 1 divided by xt minus 1. And now let us actually apply those equations for the values of 2019 and 2020. And first we are doing the calculations for the implicit price deflator, and then we are going to do the calculations for the defense expenditures. So if you are calculating the increase between 2019 and 2020 for the implicit price deflator, you know that in 2020 that value was 113.769, that's T plus 1, and in the previous year it was 112.315. This represents an expenditure, or this represents an increase in 1.29%. When you do the same calculations for the spending increase, that is for the defense spending increase from $847 billion or $848 billion to about $882 billion, you see that the defense spending in nominal terms has increased by 4.08%. However, we have seen that we have the nominal spending increase of 4.08%, but at the same time we also had a price increase. So the question is, how much did the 4.08%, how much of that was a real change and how much of that was actually inflation? And in order to do this, you have to convert those outlays or those expenditures into constant dollars. How this is conducted is as follows. So the 2020 outlays in 2020 dollars is very simple, because it does not involve any calculations, in the sense that we are still at $882 billion, a little bit over $882 billion. Now what we have to do is we have to calculate the 2019 outlays in 2020 dollars, accounting for inflation. We mentioned before that the 2019 outlays in nominal terms were $847.83 billion. And based on the constant dollar calculations that we have seen previously in this video, we can actually convert those 2019 nominal dollars into 2020 real dollars. And if you do those calculations, then those 2019 outlays in 2022 dollars were actually $848 billion, $848.8 billion. Now, based on those two values, we can now calculate the real change in expenditures between 2019 and 2020. And if you do those calculations, you see that the real change in expenditure was not 4.08%, but was actually only 2.75% because we have to take inflation into account. Note that there is a relationship also between the nominal growth, the inflation, and the real growth, which is summarized in this equation, in the sense that the real growth times the inflation equals the nominal growth. You can see this by having the real growth, which is 2.75%, times the inflation, which is 1.29%. That is equal to the nominal growth which we have observed before. Note that we also have the information for the national defense expenditures and investment between 2010 and 2020. So here, over the entire period, over the 10 years, the nominal growth was 6.58%, and you can verify that the real growth was actually a decline of 9.92%. Now, sometimes what you are interested in is not the growth over an entire period, but the average annual growth. Okay, and this is where you have to actually use the compound growth rates that calculates the percentage increase over a longer time period into annual steps. And here is the equation where n is the number of time periods between the various values. So we said that the defense expenditures in nominal terms, the defense expenditures in 2010 were $828 billion, whereas in 2020 they were about $882 billion. Now, if you are interested in the annual percentage change, you have to apply this formula, and you see that the annual percentage change in nominal terms was actually 0.64%. Note that the 0.64% is different from simply dividing the 6.58 by 10. Okay, so if you want to calculate the average annual growth rate, you have to use this equation.